Hello everyone, how's it going? In this video I will be presenting my most recent development updates on my game, which as a reminder, is a VR game being created with the Unity engine. The focus of this past development phase has been on procedurally generating dungeons for the player to explore. In order to do so, I had to conduct some research on what past dungeon designs have worked well. For the first example, I decided to look at a classic. Here I've got one of the dungeon layouts from the original Legend of Zelda. If you look to the left, you can see a tree diagram which I've reformatted the dungeon into, in order to better understand its layout as a data structure. One key element to the original Legend of Zelda's dungeon exploration progression is the use of locks and keys. In order to progress through a certain locked entryway, the player must collect a key first. If you look at the tree diagram, I've labeled rooms with keys with a K, and locked entryways with a blue arrow. The red nodes represent hubs from which spawn passageways to different branches and paths of the dungeon, giving the player choice in their exploration. I've also marked the beginning and end rooms as well as the bombable pathways, which reward a knowledgeable player with a shortcut. Pay attention to this tree data structure, as it is pretty important to understanding how the dungeon is laid out from start to finish. It provides a structure that bridges our perception of how the dungeon is shaped in a physical sense to how the dungeon can be represented in code. This becomes more essential when our dungeon designs start to become less set in stone. Moving on, my research led me to the discovery of the MetaZelda algorithm created by GitHub user Tkakzon, which essentially takes the idea of the Legend of Zelda's lock and key system and applies it to a procedurally generated dungeon. The purpose of this algorithm was to randomly generate a dungeon that must be solvable by the player with the tools provided. A simple case of this being that a collectible symbol must be discoverable before reaching the locked door that the symbol corresponds to. This can be interpreted with our tree data structure as having the symbol appear in an earlier level of the tree than the locked passageway. This algorithm would later be used in the creator's game titled Lena's Inception, where the player plays through a completely procedurally generated Legend of Zelda style game, overworld and dungeons included. Now you may be asking, what's so special about procedural generation? Isn't it just a lazy way for developers to slightly vary gameplay in order to keep players engaged for longer? Not really. Procedural generation is all about randomly generating something under the constraint that the results reflect some certain criteria. It's relatively easy to just call some built-in function to generate a random number, but what you do with that number, how you decide if it's valid, or how it affects later random generations, is all a part of a complex algorithm that the developer has to make airtight. At least with the Legend of Zelda example earlier, the dungeon will always take that shape, but with the RNG that procedural generations use, the number of things that can go wrong increases massively, and I'll get back into this with my own design. So, procedural generation isn't usually some lazy cop-out that developers can use to extend gameplay because of the extra work it requires to make sure that the random generation adheres to certain rules. Now that I've brought up a precedent for the use of procedural generation in dungeon creation, let's take a look at a game that takes this idea much further. Enter the Gungeon is a roguelike which takes a very different approach to its procedurally generated dungeons. Instead of having a lock and key system, players are actually able to travel to the end of the dungeon without unlocking some door. Instead, the game rewards full dungeon exploration with massive power scaling by allowing the players to take keys that they have and use them to unlock chests, which can give them better weapons and items. A perfect player can completely ignore this system and complete the game with stock weapons, but doing so would be tedious and extremely difficult. Instead, there is a massive power gap between having nothing and taking advantage of the key chest system, which means that the player is rewarded for purposely trying to visit every room. This creates an opportunity cost-based system, where the player has to weigh whether chests are worth the keys spent on them, whether more exploration is worth potential lost health, and how much they would be rewarded by executing a perfect boss battle, using a powerful item they pulled earlier in the dungeon, thus rewarding them with more items. Getting back to the procedural generation aspect of these dungeons, you may notice that this tree diagram of one example dungeon is slightly different from the Legend of Zelda one. What these circled subgraphs represent are macro components of the dungeon connected by the hub rooms marked in red. What Enter the Gungeon's procedural dungeon generation does is it generates these components as parts before linking them together with hub rooms. This strategy gives the algorithm that the developers created more control over dungeon generation with less edge cases, because it starts with essentially micro dungeons and ensures that they meet certain criteria before linking it all together to make the main dungeon. If you'd like to do further reading on Enter the Gungeon's dungeon generation, I'll link my article sources in the description, which is the dissection of the algorithm. It's a pretty interesting read, with the actual developers commenting on its close accuracy to the real thing at the bottom. Now moving on to what I've got to present for my game today, I'll be going over my procedural dungeon design. I started off by rigging up a couple simple room prefabs to be used in my dungeon. Connecting those rooms with hallways, I began generating simple tree-based dungeon designs, linking a start and end room with rooms in between. Here you can see that every time I press play, a new dungeon is generated. So I'm in the Unity editor with the most recent version of the project, and here I've got some of the room prefabs and regular dungeon traversal prefabs that I need in order to build the dungeon. So if I go ahead and zoom in here, I've got the start room. This is where the player starts. This red room represents the boss entrance, which the player will enter in order to drop down into the boss room here, this larger room. This orange and green room are paired together. This is the vertical send and the vertical receive, and this is where players can traverse a vertical hallway in order to get to an upper level of the dungeon. Finally, this blue room over here represents a key room, where the player will need to shoot out a target from my previous video in order to essentially collect the key in that room before unlocking the boss entrance. You can see here, with all these rooms, really, they have gaps in the walls, and those are potential entryways. If the entryway is being used, it'll be hooked up to this hallway, which will get stretched out to how long I need. Or if it's not being used, it'll be blocked off by the seal to make it seem like one uniform wall. Over here is the doorway that the player can use to enter a vertical send. So they enter this room, and they walk into the doorway and can go up the hallway, which is essentially this but vertical. And this is a corner hallway, which allows the player allows a hallway to turn at 90 degrees. And that's important for the upper room spawn. As of now, I'm using these rooms, this large room, this boss room, these two intermediate rooms. I'm not using this room, but I plan to make it a 2-entrance room, and this is the upper room, which has 8 entrances here, such that this allows the vertical sends to not have too long of a hallway in the upper level of the dungeon. Alright, so if I go ahead and click play, as you can see, I randomly spawned a dungeon with the upper room. This is the start room right here, and vertical send, vertical receive. There is a vertical, or that doorway, and the vertical hallway, and the player can go over to this big room, which only has the 2 entrances being used here and here. And this is the key room right here with the key or target in the center. You can see there's 2 more down in the regular level of the dungeon, like here, and since the keys have not been collected yet, if we try to enter the boss entrance right here, you can see it's blocked off. It's not supposed to be blocked off because there's a hallway here, but since the keys have not been collected, this room seal is still applied like it would be applied to these normal entrances. And finally, dropping in from the boss entrance, we can get into the boss room here. Right, and just to prove that it is procedural generated and I did not handcraft this, I could go ahead and click play again, and it spawns another completely different dungeon. Click it again, completely different. Click it again. Just pay attention to the start room, because it always spawns in the same place. And it's the origin right here. Yeah, so every single time I click play, I get a completely different dungeon. So going over a bit of the spawn logic here, the rooms each keep track of their neighbors. So like this start room will know this room is a neighbor, and this room will also know that the start room is a neighbor. And they keep track internally. There is no data structure all around that. It's simply the overarching spawn manager just knows the head of the graph, which will be the start room here. And when it comes to going through and spawning rooms, especially on this main level, let's say this upper component is a separate component of the dungeon, kind of like the subcomponents I was mentioning in Enter the Gungeon section of this video. But with this part, it goes through the tree. It looks at the relationships between rooms and spawns them in a breadth first search fashion. That way, the rooms closest to each other, so like this room, and this room, since they spawn off the same start room, they are given ample time to spawn before there's a lot of other rooms there to occupy space, as opposed to depth first search, which might loop back around and end up with a room right next to the room that was earlier, and that room may have another room to spawn there. And this works because I have some spawn logic in place. Let's say instead of having this room spawn this room here, let's say this room wanted to spawn this room over here in this area. Well, that would cause a collision with this room over here. So I have a system that if there is a collision with another existing room, thanks to Breath for Search organizing the rooms in the order in which they appear in the data structure, what it'll do is it'll look for the next available entrance to use with this room here, and it instead uses this. Actually, let's check my debugs to see if it ran into that problem. It did. So whenever I have this asterisk, I know that there was a collision problem, and it checks for the entrances, checks to see if there's collisions at those entrances. If it finds a new one, it'll go ahead and spawn the room there, and it'll change the data in place as well. Alright, so let's move on to the VR component. Alright, so before I hop into VR, I'm going to go ahead and spawn the dungeon first, just to make sure it's up to standard. So here we go. We got, because I'm still working on bugs, I'm constantly working on bugs. This is the key room, vertical send. I see two of them, two of each. Another key room, another key room. Everything seems fine. I'm gonna jump into VR now. Alright. So I'll try to talk louder. Actually, let me make sure to maximize this, just so it's easier to see for you. Alright. So jumping into VR, I actually didn't mention this earlier, but I did implement some more advanced movement mechanics. So I go ahead and swing my arms, I can actually increase my movement speed, and you'll see this especially when I am traversing the dungeon. And I also have one of these pistols from my last video, so I'm just going to go ahead and pick this up. This will be important later for the keywords. And I also have a jump, so if you press the primary button on the right hand controller, actually do a short jump, and I also have a crouch detection. So in real life, you're going to want to go ahead and crouch, and then release jump at the same time you uncrouch. That was for example. And there we go, and it gives you a higher jump. So this vignette effect is applied when I crouch, just to indicate to the player that you're crouched, and when I stand back up, it goes away. Alright, so let's go up the vertical receipt just to show off the jump. The timing is pretty precise. I might change that to make it more user-friendly, but for now, it serves its purpose. Gonna get ahead. Okay, so this is the first key room we're encountering. It's up in the top of in that big room up here. We can go ahead and it's on full auto. Forgot to mention that it's bound to the same button as the one that changes fire modes on the pistol. A bit of an oversight, but pretty easy fix. So I can head back down to the other vertical receive. Head back down. Alright, so now we should be in either intermediate room 4 or intermediate room 5. I think we are in, well, whichever one we're in has the branching rooms out of it. So let's see. So this is straight. Let's go straight. Oh, actually, this is straight back to the beginning. So we are actually in intermediate room 1, because that's the start. I can see another pistol there. I spawned 2. That's a start room. This must be intermediate room 1. So off of intermediate room 1 or 2 is the first key room that you would usually encounter. I can go ahead and unlock the key there just by shooting the target out with a pistol. And let's head back out. So apparently the last key room spawns off a branch from intermediate room 5. So we're in 4 now. I know that for sure. Okay, so this leads into the boss entrance room, which drops down to the boss. I can tell that's the case because this hallway is blocked off. If there was no hallway there, no passageway, this would be blocked off here. But since it's there, that's where we want to go once we get all the keys. I'm gonna head all the way down the path, and the key room should be right over here. Alright, so I show up. I'm gonna head on back to that boss entrance room, which would be intermediate room 5. Alright, so as you can see, there used to be a block here, but now there's no block here. So you can finally head on down. So the boss entrance is just right down here, and here it is. This is the boss room. This is the room that was underneath all the other rooms in the dungeon. And it gives, since there's no ceiling as of now, it gives a nice view of the dungeon generator. So yeah, it's completely procedural, yet it still provides an essentially same like list of tasks to complete. And actually, while developing, it seemed a lot smaller than it does in VR, simply because I wasn't directly standing in it. Alright, so I'll end the VR portion of this presentation and transition over to talking about the graph structure of my dungeon spawning algorithm. Alright, so moving over to the tree diagram of my dungeon, I've got the entrance marked here with this E. This is where the player starts and where the pistols are spawned. I've got the boss room or the end room marked with this B. This is where the player drops into from the boss entrance, and they can't go back up because the super jump is not high enough to go up that vertical hallway. And it's meant to be, once you reach this point, you can't do anything but exit the dungeon from there. So this green node represents the vertical send. This is the room that we jumped up from, and it was hooked up to the start room. This is also vertical send, and these orange rooms are vertical receives where we jump into those from the vertical sends. So this node is essentially, this edge right here is essentially just a vertical hallway that connects the send to the receive. This blue room is the large room with the key room in it, and anytime you see a blue node appear in the tree diagram, that's where a key or one of those targets to shoot out are. And all those targets need to be shot out in order to unlock this here edge to get to the boss entrance, as we saw by the blocked hallway in the VR demo. If you take a look at these dotted lines here, these dotted edges, these represent the fact that the RNG chooses whether or not to spawn the room off of, say, this key room off of intermediate room 1 or intermediate room 2 to change up the experience, change up the possible spawn dungeon, because there's a lot going on with the spawning algorithm. And same thing with intermediate room 4 and 5. They can be, either of them can be host to the vertical send later on in the dungeon, or the entryway to the path that leads to the key room over here. Finally, this set of dotted lines represents the fact that the path can be either 2 or 3 rooms long. So if it's 2, it'll just skip over. If it's 3, it'll head down there before getting to the key room. And once all the key rooms are, all of them are dealt with, this will unlock. The player can go to the boss entrance, which drops into the boss. Moving forward, my job will be to generate more dungeons with different sets of criteria so that the gameplay isn't just always the same, because that would get quite boring and would ruin the purpose of procedural generation, because the amount of work that went into this algorithm could have been dispersed in handcrafting multiple different levels, but the point is to create a bunch of different unique experiences, unique dungeons and such, because the algorithm allows me to make changes within a certain rule set. So there's that, and I also want to better flesh out the idea of what I want my game to be. Based on this procedural generation, you may assume that I may be wanting to do a roguelike. While that is somewhat true, I don't want to go with a pure roguelike where essentially every run is like starting the game anew. But I do want, I would like to have some permanent progression for the player to feel like they're getting better at the game. But I don't want the player to be starting every single time. So it'll be a roguelite, more so in that sense with the permanent progression. But I'll have that to report for Devlog number 3. So stay tuned.